Okay, yesterday we talked about how to find horizontal asymptotes for equations like this, but sometimes you'll want them to be rewritten in that translated form with a constant number added or subtracted on the end. So I'm going to show you how you can do that. And what we can do on this first one is we can just divide 2x plus 5 by x plus 2. I can use synthetic division there, so I'm going to do x equals negative 2. Because if I have a factor of x plus 2 on the bottom, that means x equals negative 2. My coefficients are a 2 for my x and a 5 for my constants. Synthetic division, I just bring down the 2, multiply by negative 2, add to a 1, and I have a 2 with a remainder of 1. That means my answer would be, it used to have an x, but now it's just going to be a plain number, so I have a 2. And for that remainder of 1, I can do plus 1 and put it over whatever you divided by, 1 over x plus 2. And that is how you handle that. Of course, I can see the 2 in front tells me I go up 2. So I would have a horizontal asymptote there of positive 2, which matches the way we did it yesterday by comparing the x's, saying a horizontal asymptote of positive 2, vertical asymptote either way of negative 2. That's just a way you can rewrite an equation that's in standard form into the translated form using division. Let's go ahead and work at least one more example. On this next one, I have 2x minus 1. I would need to set it equal to 0. And to find out what 0 would make, what value of x would make that factor be 0. So I have 2x is 1 and x is 1/2. It's going to be a little bit weird to do synthetic division with a fraction, but I'll show you how to do it. If x equals 1/2, I can put the 3 for my x's and my negative 3 for my constants out to the side. Now I'm going to bring down my 3, multiply by 1/2, so that is 3/2, and then 3, negative 3, minus 3/2. Might need a calculator to help you with this, but this would be negative 3/2. Now this is your remainder, and your remainder is going to remain unchanged. So the number in front, though, anytime I have a division, I basically have to multiply this by 1/2 because that's my denominator. So it's like I'm dividing everything except the remainder by 2 or multiplying by 1/2, whatever you think about. So your final answer there for this one would be I would have a 3 over 2 plus, and technically I have a negative 3/2 over 2x minus 1. There's nothing wrong with that, but and you can tell you've been translated up 3/2, but a lot of times instead of leaving that double fraction, they'll try to change it to a 3/2, and then they'll, with the plus a negative, they'll do that as a minus 3, and then they'll just move the 2 down to the denominator. So 3 and then 2, and just leave your 2x minus 1. And once again, the vertical asymptote is the amount that's been moved up by 3/2. If this one's been flipped upside down, you can see with the negative, and you can also see a vertical asymptote it looks like of 1/2 would make that equal to 0. So that's how you can rewrite it. We're going to try the last one, and this is where this is most useful. And this one does not have a vertical asymptote, but it actually has a diagonal asymptote. And the only way you're going to be able to figure that out is by division, or what it is. So I can take x equals negative 1 and divide it into 1x squared, 1x, and my negative 3 for my constant. I'm going to bring down my first one as a 1. I'm going to multiply negative 1, add 0, multiply 0, add negative 3. That means my remainder is negative 3, so I have 1x plus 0, and then that is a negative 3 over x plus 1. And I can look at that and say my vertical asymptote, because of the x plus 1, will be x equals negative 1 still. But this is going to be a diagonal asymptote. This graph would actually have a diagonal asymptote of x. So that is going to help you know what the diagonal asymptote of one of these graphs looks like. It's whatever is not left in the fraction.